In order to graph the solution set to this system of linear inequalities, we have to first graph each of the linear inequalities, and then we're looking for the regions where those two solution sets overlap. So first we graph the first inequality, and we begin by graphing the line that bounds the region 11x minus 2y equals 22. To graph that line, we need 2 points on the line. And notice that if x is equal to 0, then negative 2 times y is positive 22, so negative 2 times negative 11, negative 2 times negative 11 is positive 22. On the other hand, if y is equal to 0, then 11 times 2 equals positive 22. So we have the 2 points we need to graph this line. So negative 11, 1, 2, 3, 4, 5, 6, 8, 9, 10. Here's negative 11 way down here, the y-intercept of our first line. And at 2, 0, we have the x-intercept of that line. So this line looks something like this. Okay, so there's our first line, and the second step of graphing the inequality is to decide which side of the line do we shade. So we can ask, is the origin shaded? Here's the origin. We decide if a point like that is shaded by seeing if it satisfies the inequality. And so we wonder, if we substitute in x equals 0 and y equals 0, is this going to be true or not? The left side becomes 0, and 0 is less than 22, yes. So that's the answer to the question here. The origin is shaded. So we shade the origin side of the line. Everything over here is shaded. So, now that we've finished graphing the solution set of the first of our two linear inequalities, now we turn our attention to the second of the linear inequalities. We must also graph this one, and the overlap between, or the intersection of the two regions will be the solution set to the system of linear inequalities. So in order to do this, we first have to graph the line 4x plus 7 equals negative 28. We need 2 points, 7y. So we need 2 points on the graph of this line, and we can do it. So if y is 0, first of all, say, then 7 times 4 is 28, so 4 times negative 7 will be negative 28. And if x is 0, then it's 7 times 4 to get negative 4 to get negative 28. So those are the x and y intercepts of that line. And so we go negative 7, 0, 1, 2, 3, 4, 5, 6. Here's negative 7, the x-intercept of that line. And the y-intercept is at negative 4. 1, 2, 3, 4. So this line looks like this. And now we have to decide which side of that line to shade. And once again, we can ask our favorite question of the origin. Ask, is the origin shaded here? Now we use the inequality 4x plus 7y bigger than or equal to negative 28 to answer the shading question here. So if we substitute x equals 0 and y equals 0 here, the left becomes 0, and 0 is indeed, it is, yes, bigger than negative 28. So the answer to our question about the shading, is the origin shaded, is yes, the origin is shaded. So we have to shade the origin side of the second line here that we just graphed. Now we're interested in where the two regions actually intersect, so the solution set of our linear system then is everything along this bounding line and then up along this bounding line, including the bounding lines, because it's or equal to, and everything in this wedge in between going on. So that is the solution, the graph of the solution set to our system of linear inequalities.